In this video, I'm going to continue going over the practice questions for grade 9 ASP. This is for the end of term 1 exam. So in this question over here, a car with an initial velocity, VI, slows uniformly to this new speed, which must be VF. I like to label what I have. In this much time, that's seconds there, so that's a T. I don't know what's happening with my mouse. What is the average acceleration of this car? So I need to find A. If you remember the formulas that we were using, this is going to be related to the formula V final is V initial plus AT. Of course, we just need to rearrange this formula to get A. If you remember how to do that, it's V final. This is plus, so that means this will now go to the other side and it will become subtract V final minus V initial, and then equals A. Well, this is multiplying with the T, so to cancel it I will divide both sides by T, so that will bring that across, and that will be something like this. This is final minus initial divided by time, change of speed divided by time. Okay, final, as we've identified, was 6 minus the initial 16 divided by 4. That gives you a calculation. If you use that, you will get 2.5 minus 2.5. That means it's slowing down, so you can write minus 2.5 because remember it's a vector, or you can state the direction. If he's moving east, the opposite of east is west, right? If you've forgotten, you can check your compass like this. Never eat something wet. East is on that way, the west is that way, so opposite directions. Now, the biker below starts moving from rest, so that means V initial is rest, so that's just 0. He is not moving. With a constant acceleration of 2.5, that's A. Calculate the speed after 3 seconds, that's T. Back to the formula, V final equals V initial plus AT. V initial was 0 because it started from rest, plus A, 2.5, times the time, which was 3, and you will get your answer directly, 7.5. Find the change in his speed between T is 4 and 5 seconds. So you want to find the change in speed. Again, you will just do A times T. Just like before, 2.5 times 1. We're not really interested in the starting speed, we just want to find the change, so that will be my change in speed right there, A multiplied by T. Very good. Now we're moving on to some more graph stuff. So let's see. We now have a velocity time graph. Which of the 4 trains is slowing down? So remember, as we know, acceleration is the change of speed over time. That's like rise over run. Speed over time, rise over run. Acceleration is a slope, so it's asking for slowing down. Slowing down means the slope must be negative, a slope going downwards. We can clearly see here that D is a slope going downwards. So D has something slowing down. Let's go through them all, however. A, you can see it's speeding up. It's speeding up with a constant acceleration. If you can see this one here, this is C. The velocity is not changing, so you can say this is constant velocity. The velocity remains constant. Finally, we also have this one here, B. This is also speeding up, but it's not constant acceleration because the acceleration is changing. It's getting faster and increasing faster and faster as it goes. It is not increasing its speed uniformly, it's increasing its acceleration as well. Very nice. Next we have this other one. This looks a bit messy, which is moving with a constant velocity. So as I've shown you already, a straight horizontal line is a constant velocity. So clearly I can see A and I can see E, these two. B is increasing its velocity. C is decreasing its velocity. D starts by decreasing to the negative side and then remains at a constant negative velocity. So based on this, I can see that A and E throughout the whole journey, they're the only two. Constant negative acceleration, I've just given it away. It is this one here. It is C. Okay. Now we have another graph. let's see what's happening. When is the acceleration 0? Well, as you know, in a velocity time graph, the acceleration will be 0 when it's a horizontal line. So this is speeding up. A, we would say, is speeding up. At B, it's constant speed, so B, we have 0. C, we can say slowing down, going to the negative, and then this is also going back to the positive side. So the acceleration being 0, we will say B. This is a graph, again, representing the motion. You have to identify A, B, C, D, and E. So again, as we are now hopefully professionals with this, we can see that this has positive acceleration, constant velocity, negative acceleration, also negative acceleration, and positive acceleration. So positive was only A and E. 0 was B up here. And slowing down was C and D. Wait. Okay, there's a mistake on this. C and, what's this? That's supposed to be E actually, not D. Why am I saying this? Slowing down is C. This is actually quite important actually. I never really mentioned it earlier, but let's go over it now. This is going towards 0. If it's going towards 0, of course it's slowing down. It's negative because it's going towards the negative side, so that is going to be slowing down. But even though D is negative, it is going towards the negative, but actually, look, it's speeding up at the negative side. -1, -2, minus whatever. It is actually negative, but getting faster. So it could be maybe traveling to the left, for example. E is positive, that is true, but it is actually slowing down. It was in the negative side, now it's going back towards 0. It'll slow down, stop, change directions and go up. That's an important point. I'm not sure if I mentioned that earlier, so that's something that we need to consider as well. So this question over here said slowing down. You would assume C and D just by off the bat by looking at it, but no, be very careful. Going towards 0 is slowing down. Moving away from 0 is speeding up, no matter which direction. So keep that in mind. Next, we have this particle model. So looking at this particle model over here, you can see at the beginning, it is quite slow, but then it gets faster and faster and faster and faster. So this looks like it's accelerating. And he is traveling to the right. One thing to note is we are going to take right as positive and we're going to take left as negative. So this is originally facing to the right, so the V is in the positive direction. It's getting faster, so we can say the A, I'll write it over here, we can see the A is also in the positive direction. Both are positive, and we know it's speeding up. Over here, let's have a look. Now it's going to the left, so I can see that the V is to the left. And now, it starts off fast, it's got big spaces, but then it's slowing down. So in order for it to slow down, the acceleration must be in the opposite direction. The acceleration must be to the right. That way, they're going to cancel each other out. It will slow down. So V is negative, A is positive, and as I've mentioned, it is slowing down. Next one over here. We've got an object, the velocity, well that's going to the right, that's easy to figure out, it's going to the right. But let's see, starts off quite fast, lots of spaces, and then the spaces get closer and closer and closer, which means it's slowing down again. In order for this to slow down, the acceleration has to be in the opposite direction. If it was in the same direction, it will speed up. If they were both going to the left, it will again speed up. But right now, they're opposite directions because it's slowing down. So V is positive, A is negative, and then it is slowing down. Now, same thing. Let's have a look at here. What does it say? It's moving from left to right. So the V is in the right-hand side. So we know the V is positive. Now, if this is looking at this, they're getting closer and closer and closer, it's slowing down. The only way it can slow down is if the A is to the left. That's the only way this will slow down. These are equally spaced. If they're equally spaced, then the speed is not changing, it's constant speed. If it's constant speed, there is no acceleration at all. Finally, this is going to the right, of course, as it says up above. It is getting faster. So if it's getting faster to the right, the acceleration must also be to the right in order to speed it up. That's why we can say the acceleration is positive. Okay, so now we're going to answer this question over here. We have a boy accelerating. If he accelerates from rest at this, what is his speed after this much time? It's exactly the same as the questions that I did with you earlier. We have V final equals V initial plus AT. We will stick with this formula for this one. That is supposed to be a plus. Let me try that one more time. Plus AT. I want to know his speed after 3.2 seconds. So I need the final speed. I have the acceleration, meters per second squared. I have the time, and it says from rest, so V initial is 0. So V initial is 0 plus 1.2 times 3.2. Putting that in your calculator, you will get 3.84. Okay, so now we're looking at displacement time graphs. Oh, velocity time graphs, but we're finding the displacement in them. And this is straightforward. As you already know, the slope, that tells me the acceleration. The area under the graph, that tells me my displacement or distance traveled. We can call it displacement. How do we know that? Well, we remember the formula, and I gave you the triangle before. The formula for this was V equals x divided by t. If I rearrange this, I want x equals, that will be, take the t across, that becomes V multiplied by t. V multiplied by t. If I multiply them, that is the same as the area under the graph. But in this specific case, it's like a triangle. So I have to take half of it. So if I was to calculate area under the graph, V multiplied by t would be like a rectangle, length times width. Like this part here, length times width. This would be a nice little rectangle or a square, length times width. Of course, if I have half of that, if I take this and I have this cutting it in half, of course it's half times length times width, which clearly is just the area of our triangle. So back to the question. This question is just asking what does it represent, and I've just mentioned it, displacement. Over here you need to now calculate the displacement. Which displacement are we calculating? Steady positive acceleration. So again, this is accelerating positive, this is constant speed, and this is slowing down. The only steady positive acceleration is this part here. That means I will take this triangle. I will do a half length times width or a half base times height. Call it whatever you like. It's the area of this section here, which is a triangle. A half times 5. Okay, forgot the half. Oh God, I'll try that again. A half 5 times what? 5 times 5. 5 times 5 is 25. Half of that is 12.5. Very good. There's another multiple choice on this side. I'll do that next. This is showing another velocity time graph. What is the displacement from 0 to 4? So from 0 to 4, I only need this displacement here, not that part. So again, it asks for displacement, which means area under the graph. It did not ask for acceleration, it's asking for displacement. Area under the graph, length times width. It is not a triangle anymore, so we will not need to do half anymore. So I'll just do length multiplied by width. I have my length, which is 4, and I have my width, which is 40. There you go, 4 times 40, so 4 times 4 is 16, add a 0, 160. There we go. And I'll do this one last before I move on. Let's see, we have this graph with this motion, very nice. Find the displacement, okay, same thing. But now it said total displacement. So I need the whole displacement. I can see that I have two shapes here. I have a triangle and I have this rectangle. I have two sections, 1 and 2. I have to add both of them. So I will find the total displacement as written over here. It is the triangle plus the rectangle, which is a half times the base times the height plus the square. I'm just writing it here. It's already written, so I'm not going to waste time writing it again. A half times the base times the height. So that's 4 times 10. A half of 4 times 10. Plus, this between here and here, this is 2 seconds long. 6 minus 4, that's 2. So you can write 6 minus 4 like they did here, or you can just write 2. Multiply that by 10. So this is 2 multiplied by 10. You will get 20 plus 20. The final answer is 40. I will stop that one there.